All right, so one of the cool thing about colligative properties is because it only depends on the amount of moles, we can actually use colligative properties to determine molar masses, right? So you can set up experiments using colligative properties. Can be used to find the molar mass of a compound. And that's extremely useful because if you think about it, a lot of chemistry is identifying what something is. So if somebody hands you some compound and asks what it is, one of the most useful pieces of information you can obtain is what the molar mass is, because those are very rarely the same for most compounds. And so if you know the molar mass, you really, limit the number of things it can be, and it can help you identify what the compound is. So remember, molar mass is equal to grams per mole. And so we need to know two pieces of information in order to know the molar mass, right? We need to know the mass. That's relatively simple. You can just take a solid and you weigh it. So you're going to weigh your solute. And then the moles, right, that can be determined from the experiment using colligative properties. And so if we think about our freezing point depression and elevation, the change in the freezing point depression or elevation is just some constant times the molal. The molal is equal to the moles of the solute over kg of the solvent. And so we can take this value here and then plug it into this molal. You get delta T is equal to K times your moles of your solute over kg of the solvent. And then we can solve, or we can reorganize this equation to solve for the moles of the solute. So in this case, your moles of your solute will be equal to delta T times the kilograms of the solvent divided by K, which is a constant. So we can find the change in the freezing point experimentally. The kilograms of solvent is just how much solvent you use, and divided by K, which is just a constant. So that gives you the moles of solute. Once you have the moles of solute, as long as you weighed it, you can find out the molar mass. The other way is right through our osmotic equation. This osmotic pressure equals molarity times R times T. Remember that molarity is equal to moles of the solute over liters of solution. So again, what we can do is we can take this value right here, plug it in for capital M. We get a new equation that goes something like this. And then you just reorganize this equation to solve for your moles of solute, right? In this case, you want to divide both sides by RT and then multiply by liters of solution. And so again, that allows you to solve for this moles of solute. And as long as you weighed your compound before the experiment, you can know the mass, and thus you can figure out the molar mass. So definitely check out the work along. These problems can be a little bit tricky, but do a couple of them and it shouldn't be too bad.